Hello there guys, welcome to my channel. Okay, in this video I'm going to explain to you about the electrolysis chapter covered for IGCSE and also O level. So this chapter is electrolysis. So I'm going to discuss about the electrodes, electrolytes, purification of metals, and also all these four cases involving electrolysis: molten, aqueous, concentrated solution, and also change of electrodes. Alright, so now let us go to the first one. Okay, for electrolysis, here is the explanation that I have made. A breakdown of ionic compound into its element by using electricity. Okay, now for this is, we call it as an electrolyte. Alright, this is an electrolyte. So it should be in a molten or aqueous form. Okay, that it has some ions, positive and also negative ions, that conduct electricity. So that is how the current, so always remember the current can flow through here and then it is being conducted by the electrolyte. Okay, so remember from here to here is current and the electron will be moving in the opposite direction. Okay, now for electrode, the commonly used is carbon and platinum, but platinum is quite expensive to be used in the industry, so they'll be using carbon in the most case. Why they are using carbon or platinum? Because it has it is inert. Okay, it is stable and it does not react with these electrolytes. Okay, now we go to the first one, molten solution. Okay, now example here I'm going to give a molten solution of sodium chloride. Okay, NaCl. Okay, now the ion exists here is sodium and sodium positive. This is a group 1, and we also have here chlorine. Okay, chloride ion here. So what's the difference between a molten and also aqueous? Molten, there is no water contained, there is no H2O. Okay, so please remember this. So now when you have here, okay, and then here is a positively charged, right? So this one will become anode. And here's negative, and this is one will become a cathode. Okay, so always remember, anode is not always positive. So anode is a place where, let me write it down over here. Anode is a place where the electron is being released. Okay, electron is being released. So this is the definition of an anode. So but in this case, electrolysis cells, we will make the positive charge here as an anode. Okay, so now when you have chlorine ion negative and sodium ion as positive, so obviously the negative ion will be attracted to the anode. Alright, so ion attracted to anode is a chlorine or chloride ion, and ion attracted to the cathode is a sodium. Okay, so now what happens over here is the half equation. So what happened exactly in this stage, here and here, you will have a discharge process will be going on. Okay, this one I just mentioned here is a discharge process where the negative will become a normal atom and the positive ion will become a normal atom. So now here for half equation, the anode, so here we will have chlorine and it will release the electron. Okay, so as you can see here, it releases the electron. So electron will be going upward as the opposite direction of the current. So electrons, this is the electrons movement. Okay, now for chlorine, this chlorine, it appears as a Dewey atom, right? So you have to put here 2, 2 and 2. So this is the half equation of the anode. So now let us look at the half equation at the cathode. Now we have sodium ion. So once it is a positive ion, you have to accept the electron to become a neutral atom. So in this electrode cathodes, so here we will have a sodium deposited. Okay, now the product at anode and also the cathode. So as you can see, this one, it will form as a chlorine gas, and here you will have a sodium metals. So I hope you understand about molten solution. Now let us go to aqueous solution. Okay, now for the aqueous solution, so let me make it as a aqueous sodium chloride. Okay, aqueous sodium chloride. It means it contains water with water. So with water, it means you will have additional 2 ions, which is hydrogen ion and also hydroxide ion. So ion exists over here. You will have the remaining sodium and chlorine plus with the hydrogen ion and hydroxide ion. Okay, so this is the ion axis over here. So now we are going to, I'm going to explain to you about the ion attracted to each anode and also cathode. So here's the anode and here's the cathode. So since it is positive, you will be attracting chlorine or chloride ion and hydroxide ion. Alright, so the 2 ions will be attracted here. However, at here you will have all the positive ions, sodium and also hydrogen ion. Okay, now the problem is we have to decide which one of these will be discharged over here. So for that, we are going to look at the electrochemical series. Okay guys, so this is the electrochemical series over here. This is the most reactive. Okay, this is the most reactive. And this is the most, you can see the least reactive. Okay, the least reactive. So below here we will have a gold, which is aurum. Okay, below this. So you can keep a gold bar for centuries, and there is no effect, there is no oxidization. But if you keep potassium or sodium, alright, these 3 metals, it will oxidize easily. So this is what it means. So now how do we apply sodium and hydrogen here? Now let us determine its position. Sodium is here, the most reactive, and hydrogen is here. So now the rules is we have to select the most lowest, okay, the lowest position. So now example, the lowest here is a hydrogen. Okay, so hydrogen will be selected to be discharged at cathode. Now let us look at the anode side. So we have chlorine and also hydroxide. So we have to choose hydroxide since it is the lowest. Okay, now hydroxide is chosen. Okay, now okay, ion attracted to anode. So let me write it down first. Chloride and also hydroxide. And here we will have a cathode, sodium and a hydrogen. Okay, half equation, since hydroxide and hydrogen ion will be selected. The half equation at anode, please remember this. if you have a hydroxide ion, you will have water. Okay, you will have water and oxygen. Water and oxygen. Please remember this. Okay. And you please remember there is a 4 here and there is a 4 here. Stands for the electron. So this is how we balance it, the equation. So please remember, if you have hydroxide, you will release water and oxygen. Okay, now for cathode, you have hydrogen. It will accept electron and form a neutral atom of hydrogen. But in the room temperature, what happens here is the hydrogen will be combined with another hydrogen to form the molecule. So here we have to add another 2 and 2 here. So the product at anode is oxygen, and product at the cathode here will be hydrogen gas. Okay, so this is the addition thing for aqueous solution. Alright, so I hope you can understand this. Now let us move on with the concentrated solution. Okay, now we have here concentrated solution. So what's the difference between an aqueous and also concentrated solution here? Okay, for aqueous solution, you will have, okay, let me combine this. Okay, so you have the main and then you have a water contained. So for aqueous, you have here both 50% and 50%. Alright. However, for concentrated, you will have less water. So which means your water here will be only about 20%, and the main sodium chloride here you have about 80%. So the chances of a sodium chloride to be discharged is much more higher for concentrated. So now let us look back at the question. So now here we do have a concentrated sodium chloride. So the ion exists. We still have sodium, hydrogen, chloride ion, and also hydroxide ion. So remember, if you have concentrated, it only gives effect at the anode. Okay, only at the anode. So the same with the aqueous, which is this. So here you will have the same thing. At anode, you will have chlorine. Let me change the color. Chloride ion and hydroxide ion. At cathode, you will have a sodium ion and also hydrogen ion. Okay, so now at your anode, here you have chlorine and hydroxide. And please remember the percentage that I mentioned to you just now. This is about 80% and this is about 20%. So your chloride will have the highest possibilities. So you will have a chloride ion being discharged. And it appears as a diatom. Okay, and then for cathode, you will have the usual thing, okay, which is hydrogen. So hydrogen will be discharged. You accept electron to form hydrogen gas. Okay, the product here will be chlorine gas and also hydrogen gas. Okay, so if you have a question on a concentrated solution, normally you will be focusing at the halogen, so which is under for chlorine and also for bromine. Okay, so this is the example for concentrated solution. Okay, the next thing here is the change of electrodes. So previously all these examples I'm using a carbon. So let me change this to copper. Okay, copper rod. And I remain this with the aqueous of sodium chloride. So your ion exists over here is sodium, hydrogen, chloride ion, and hydrazide ion. Okay, remember I can mention in the beginning, which is this. Okay, the carbon and platinum is inert. It means they don't react with the solution. However, if you look at this change of electrode, when we are using copper, the copper will have the reaction. Okay, so let us look at the ion here. Here you will have chloride ion and also hydrazide ion, right? So what happens is, let me write down this one. Okay, so what happened at your half equation is the copper itself will be dissolved and it will produce ion and electron. So none of this will be selected. So it only happens at anode. Okay, now at cathode is as usual. Okay, and you will have a hydrogen ion to be discharged because it is lower than the sodium. So you'll have hydrogen 2, 2, 2. So half equation, remember half equation, you must have electrons over here. Okay, so for anode you don't have a product, but at the cathode you will have a hydrogen gas coming out. And what is your observation here? And you can notice that the rod here, right? The rod here will be slowly getting thinner and the water will become blue in color due to copper 2 solution. So this is a change of electrodes effect. So remember, both the concentrated and also change of electrode, it will effect on anode only. Okay, now let us look at the application here. The first thing is electroplating. Okay, electroplating, let's say we have old keys, right? Old keys, and you want to plate with silver. So let me, I have made here the description. Let me try to make my writing a bit bigger. I hope it helps. Okay, for electroplating, the cathode, at cathode, so this is the cathode, right, and this is the anode. So this is the object you want to plate. So you have to install the object that you want to plate over here. It can be old keys, keychain, or some other metals you want to plate. Okay, this is the keychain, key. Okay, now example, I want to plate with silver. You have to attach a silver rod. Okay, so I just put there AG rod. So this one will become a argentum rod. And your electrolyte, you have to select something to do with the argentum itself. Most commonly, you just have to attach with the nitrate. Okay, like a argentum nitrate, copper nitrate. Okay, now the ion axis over here is make sure it is aqueous. So you have argentum plus, hydrogen plus, and then you have a OH, and you have a nitrate. Okay, so now the main thing here, what happens at the anode? As we look at the previous lesson, we have a change of electrode. So this is argentum. So you will have argentum rods, right? You will change to iron and it will release electrons. So here you will have a argentum ion from the rod, and not forgetting you also will have the ion from the solution itself, the electrolyte. So at cathode you will have argentum ion absorbing electrons to form the metal. So the whole key will be plated with silver. Okay, will be plated with a silver, and it takes some time depending on the power supply. Okay, now for your half equation, oh yeah, this is supposed to be the half equation here. Let me just copy it down, and here. So ion attracted, so at cathode you have this, so which means this is not workable, and here we will have argentum ion and also hydrogen ion. So normally for electroplating questions, they will ask you about argentum or copper. Okay, this is the two common thing will be used for electroplating. Okay, for purification of metals, so let's say we have this is anode and this is the cathode. So at cathode we will put a pure metal rod. Let's say we are using a copper now. Alright, so we are using a copper rod. So this is a clean copper rod. And you have a very old dirty copper, right? So it will be placed at the anode. Okay, so this is a dirty old dirty metal rod, so copper rods. And since you have selected we have selected copper, so make sure your electrolyte will be something to do with copper, like copper nitrate or copper sulfate. Okay, so for ion exists here, so you just have to take from here the solution. So you have Cu2 plus hydrogen, sulfate ion and hydrogen ion. So now ion attracted a 2. Okay, let me just write it down here. We have sulfate and hydroxide. At cathode we have a copper 2 plus and hydrogen plus. Okay, now since both of this is it's not a carbon, right? So what happened over here is the rod at the anode, this one, they will dissolve and it will form copper ion and it will release electron. So as the time goes on, the rod will be thinner and thinner and thinner, something like this. And all the dirts, okay, all the dirts will fall here. These the dirts. Okay, then after that you will have a copper. Okay, the copper ion will be attracted and deposited here. Deposited at your cathode. So which means the rod at the cathode here will be fatter and fatter and fatter. Okay, so this is the example of a purification of metal for electrolysis. Okay, let us answer some of these past year questions on electrolysis. So a student carried out an electrolysis experiment using an apparatus shown. This is the apparatus. So we have a carbon electrode and dilute sodium chloride. Okay, the student uses a dilute aqueous sodium chloride. Okay, state the name given to any solution which undergoes electrolysis. So this is electrolyte. Okay, electrolyte. Okay, now you have a 1 mark here. Now hydrogen ion will be discharged at anode. So this is hydrogen ion. So do you remember this equation? So now we have here 4 and it releases water and you have 4 electrons already mentioned. So to complete this you have 2 marks. Explain how the ionic half equation shows the hydrogen ion are being oxidized. Explain how. So which means this one it requires the knowledge of a redox. So let me use a green color to explain this. Now when you look at OH, so let me do it down here. When you look at OH, their entire oxidation number is equals to -1. Now let's say we want to calculate for oxygen, right? So we just put as a X. So hydrogen normally it appears as a positive. So we just put here +1. So now to find the oxidation of the oxygen here is, so you got the -2. So go back to the question. So here we have oxidation state of oxygen is -2, and here it becomes molecule, which is 0. So you can say increase in oxidation state or oxidation number. Okay, so you can also mention -2 to 0. You get 1 mark here. Okay, describe what the student observed at the cathode. So at the cathode, what happens here? So what happens here is, if you look at the dilute, so we have sodium ion, chlorine, hydrogen, and here we have so we can abandon this one, it happens at anode. So they're asking what happened at the cathode, right? So obviously this one will be discharged. So what happens here? It will absorb electron and it will get hydrogen gas. So you can say there's a bubbles coming out, okay, bubbles coming out or fizzing. So you can say there is a bubbles or fizzing. There is many other words. 1 mark here, bubble form. Okay, now the next one. Write the ionic half equation for the reaction at the cathode. So which I've already mentioned there. So which is this? Make it 2, and here's 2, and here's 2. Let me write it back. So you have here +2 electron, right? So this is 2 marks. Okay, now let us move to the next question. Dilute sulfuric acid is electrolyzed using the apparatus shown. So okay, so we have here inert means it's a carbon or platinum. So here we have a dilute sulfuric acid. So let us separate this. So what happens here? We have a hydrogen ion and also sulfate ion and hydrogen ion. So this is at the anode side, okay, at the anode side, and here's at the cathode side. So OH will be selected, OH, and then remember the equation, guys. So here we have water, oxygen, and 4 electrons. So here we will have oxygen coming out, and at the cathode, here's the cathode. So here we will have a hydrogen coming out. We will absorb the electron to form hydrogen gas. Okay, now first question, state what is meant by the term electrolysis. So you can say a substance. Let me write it down for you. Okay guys, so this is my short answer here. Ionic substance in the form of molten or aqueous solution that consists of a moving ion, positive and negative, so that it can conduct electricity. Okay, this is 2 marks. Now let us look at the next one. Okay, explain why inert electrode are used. So it is not reacting with the dilute sulfuric acid or any other electrolytes. So guys, this is my answer. So the electrode will not react with the electrolytes. Okay, now name the product formed at each electrode, negative and positive. So this is cathode and this is anode. So as you can see, I have discussed with you just now. So here we will have oxygen and here we will have a hydrogen. So at positive you have oxygen gas going out and here we will have a hydrogen gas. Okay, write an ionic half equation for reaction at the negative electrode. So you can write hydrogen 2, 2 and 2. Okay guys, so this is the second past year questions. So I hope you can understand this chapter very well now, and all the best for your revision. Please like and subscribe. Thank you guys.